Thank you very much. And thank you everybody for taking the time to come here. My name's Yatharth Gupta. I'm the PM manager for Azure Databricks. And what we wanted to do today is we want to spend 15, 20, 25 minutes talking about how to build a modern data warehouse with Spark. And I'll keep some time for Q&A, and thank you for the very large audience. So just show of hands, how many people here work on data warehouses? Excellent. How many people work on Spark? How many people work on neither of them? Excellent. All right. So we'll get started. We're going to talk about three things. We're going to talk about traditional data warehouses, how we see customers use them, what they are good for. We're going to talk about what has changed over the last 5, 10 years. Why are we talking about a modern data warehouse? And we're going to talk a little bit about how to build one. And throughout my talk, I'm going to use an example of, I'm a big fan of windmills, so I'm going to have a windmill Inc., and I'm going to show you their evolution, how they had a traditional data warehouse and where they've gone from there. So traditional data warehousing, there are lots of different ways to look at it. I've kind of simplified this, but typically what happens in a traditional data warehouse is you have data coming in from ERP systems, you have data coming in from CRM systems, maybe some marketing data, and you have a bunch of your operational systems. All of this data is available in different places. It's gathered, it's transformed, and it's loaded into a data warehouse. And then customers run reports on them, and then they do ad hoc queries. So you can think of, if you were a retailer, you'd have your point of sale data that goes in, that'd be your operational system that you take, you'd ETL that data, you'd put it in a data warehouse. And it's a super powerful concept because you can ask it a lot of questions, right? You can say, how did your month do? How was your last quarter? Analysts typically use this data warehouse to do all sorts of analysis. That's how a traditional data warehouse typically worked. And there are a lot of tools. Like this is not something that can be easily changed because from a data warehouse, what we see is customers have a lot of different tools that they attach to a data warehouse. So there is an ecosystem that's built around data warehouses. So if I were Windmills Incorporate, these are the kinds of things I would do with my traditional data warehouse. I'm a windmill company. I produce power. I sell power. So I would do things like, how much power was produced? This is a question that I would ask my data warehouse. What was my maintenance cost? Has it grown? Has it decreased? Was there any wastage? Because one of the things with wind power is if you produce more than you can sell, then there is wastage because you can't store that power. So what was my wastage? What is the analysis of different markets? Am I selling in the right markets or not? These are some of the very interesting business questions that analysts ask of their data warehouse. But guess what? Technology is changing. Landscapes are evolving. Over the last 5, 10 years, we've seen cost of computing go down. At the same time, the power of computing has gone up. Costs of storage have declined, and the cloud has become more prevalent. What does this have to do with a data warehouse? What this essentially does is, historically, people stored only the most important data. This is no longer true because the cost of storing data was very high. People only ran computations that were super important. They didn't have time for experimentation or resources for experimentation. This has fundamentally changed, and people are putting stuff on the cloud, reducing their DevOps. So these are some of the things that have changed. Data warehousing, how did the cloud help data warehousing? One of the simplest things it did is you used to have a data warehouse on-prem, and now you've moved that up to the cloud. When you move it up to the cloud, your total cost of ownership reduces. At least that's what we hear back from customers. That's what our data tells us. Customers can now run these data warehouses on faster hardware. They can have elastic scale, some of the common things that you get with the cloud. And they are running more workloads because they have this elastic scale. They grow their data warehouse. They run more workloads. They run more complex workloads. But if you think about it, just moving stuff to the cloud has a lot of positive impact. But from a business perspective, you're still asking the same questions. So you took your massive data warehouse that was on-prem, you put it on the cloud, and it's faster, it's elastic, your finance guy is happy because it's cheaper, but you're still doing the same old pattern. You're asking these questions. What happened? Why did it happen? Sort of top-down analysis. These are very powerful questions. Like, don't get me wrong. Like, these are very critical questions. But I think technology can help us here. Like, the world is advancing, and we can change the pattern of data warehousing to answer many more questions. If you look at our windmill, 5 years have passed. They've updated their logo. Same pattern, right? What was the power produced? What were the maintenance costs? What was the wastage? And what was the analysis on markets? One of the things that has happened with the shift to cloud computing is not just about compute power and storage costs going down, but there's high volumes of data being generated. Like data that was either not being generated or was thrown away is now being stored. And businesses have new dimensions to data. So if you think about a windmill farm, they would calculate how much energy was generated by doing a meter reading. That's old school data collection. New school data collection is they know every hour how each component is performing in the windmill. So there is a lot more data. Taking all of this, putting all of this together, we start to think like, how can we do better? At the end of the day, our goal, the goal of the business is to increase operational efficiency, right? That's what we want to do. That's why the business hires engineers and analysts to write code to help them get those insights. It is time, we believe that it is time to ask different kinds of questions of the data warehouse. Not what happened, but what will happen. How can I accurately say what's going to happen next month? Not why did something happen, but how can we make something happen? Rather than going and doing an evaluation on, did the windmills do well last month, we should be talking about what does it take to generate 20 megawatts of power. So here is some very interesting ways that we see people, enriching their existing data warehouses using Spark, and I'll get to the Spark part. But here are some of the very super interesting things people are doing. Like this was fascinating to me when I learned about this from talking to customers. The windmill company can take pictures using drones of the vegetation around the windmill farms, and they can run deep learning on it to try to figure out whether the vegetation is going up, going down, and they can map that with how much, what's the impact of that on the generated power. They're running machine learning models for every single windmill that they own, data coming from every single sensor to, sorry, I kind of skipped ahead. But the other thing is like looking at weather data. So weather data is available from the government agencies, weather forecasts. They're taking all of that data, putting it together, and seeing what is the impact of that on power generation, right? Like they're getting insights like when it's going to rain, is the power going to be more or less? Like they're going to do predictive maintenance. They're getting sensor data from all of the windmill components, and they're trying to figure out when the windmill is going to fail. Imagine if you could take all of this data and augment your data warehouse. Now you are looking at a situation where you're asking your data warehouse, very intelligent questions. You're asking your data warehouse, hey, what would it take to produce X amounts of power? So we're going to supplement our data warehouse. We're going to read data from all of these new diverse sources. We're going to put ML AI on this data. We're going to constantly update our data warehouse, and we're going to leverage this new data. So the windmill company can now predict how much energy is going to be generated. Why is this important? This is important because they can better plan on how to sell this. They can figure out what pricing is the most optimal pricing based on knowing, how much energy is going to be produced, what's going to be the wastage, what the markets are going to look like. They can accurately estimate what the return on investment is going to be on maintenance. So if they know that windmills are going to fail, and if they invest X amount of dollars in trying to fix those windmills, then the return on investment is going to be higher. So pretty amazing things. But how do we put all of this together? I talked about a data warehouse, and I talked about ML. And when we go and talk to customers about this, it's always like, yeah, great, Spark does ML. You're telling me something that I already know. I already have a data warehouse. What is the fundamental challenge here? The fundamental challenge that we want to help everybody out with, that I would like for you guys to take away, is how you can leverage all of these things together and build a solution for your organizations that can have a streamlined pipeline to answer all of these questions. So, I know this is Spark Summit, and I'd like to talk more about just core technology, but I am from Microsoft. This is a sponsored talk, so a little Azure plug on how you would build it, how you'd build this pattern. There's a couple of things that you need to do. You already have a data warehouse. You can now get structured and unstructured data, whether it's streaming or it's batch data. So imagine if you have windmills spinning out sensor data, you could use Kafka or you could use Events Hub, IoT Hubs to get that data and feed it into Azure Databricks. And you can run ML models on that. If you have batch data from your existing line of business applications, we have multiple tools, multiple connectors available through Azure Data Factory that help you bring in that data, land that data in a data lake that can be then analyzed using Azure Databricks and Spark. We have very high-speed connectors that push the data from Azure Databricks to a SQL data warehouse. So what we have essentially done is we are making a bet that this is going to be an important pattern moving forward. The marriage of the power that Spark brings and a data warehouse in the cloud, and we have built each of these connectors as like a couple of lines of code for you. So if you were to build this, you create an Azure Data Factory, it helps you orchestrate the entire flow. If you are in Spark, you can write to a data warehouse. Like every Spark node could write to a data warehouse node. We have built this for you to make it easier for you to start building your business logic. And once you put stuff in your data warehouse, you can do amazing things, right? Like you can do 100-way joins. These data warehouses, they're very powerful as a serving layer. And also, there's a lot of tools that are already built into it. So the idea of this pattern is before data gets to the data warehouse, how do you infuse it with more and richer intelligence? And once data is in there, you can use your serving layer. I put Power BI up there. That's our sort of reporting layer. But this pattern will fundamentally, we believe, will fundamentally change how people think about data warehouses. You build this. We of course would ask you to come try out Azure Databricks. That's our Spark offering. It's integrated with Azure Active Directory. So a little bit about the product. You guys are super familiar with Spark, but when you're using Spark in an enterprise environment, one of the challenges that we see from our enterprise customers is, hey, Spark uses some different kind of authentication. It's not tied in with my org identity. That's a problem we have solved for you. So when you use Azure Databricks, you're going to get Active Directory integration. You're going to get SQL DW connectivity. It's going to integrate with Data Factory. How many people know what Data Factory is? So Data Factory is essentially a cloud service that we provide as part of Azure that helps you orchestrate different things. So think about if you're getting data from source A, landing it in your data lake, then running analysis, you need something that says, do this first, then do this other thing. So Data Factory is a very powerful tool that allows you to do that. If you're getting streaming data, which we see a lot of our customers, especially in the industrial automation side, going in that direction, you can get streaming data through HD inside Kafka. You can do IoT Hub, Event Hub. These are all engines that help you get streaming data. They do slightly different things, slightly different flavors of each other. And of course, we connect to Power BI. If you had operational needs, you could pull and push data from SQL DB or Cosmos DB as well. So, putting all of this together, we think that when you combine everything and build this pipeline, you're going to have a super powerful data warehouse, and your time to building this is going to be super low on Azure. With that, short talk, I'll close with that. I'd encourage everybody to go ahead and try this out. And I'm going to stick around here for questions. We have some time, so if there are any questions or comments. Yes, sir. Sorry, I heard, can you unpack the SQL DW plus Spark?
Yeah, what are some examples of why you would want to?
So one of the most common examples is when you want to add a dimension to your data warehouse that is inferred from machine learning. let's say you're getting data. I'll continue with my windmill example, right? Let's say you're getting data from windmills, right? So your data warehouse knows how much energy is being produced, but you want to add a different dimension to every windmill saying, when is this windmill going to fail? Or what is the probability that it's going to require maintenance in the next month? You can run machine learning models in Spark to get that insight and then feed it into the data warehouse. Does that make sense?
Yeah, that makes sense. You can score it and speed up the Spark that way, right?
Sorry?
You can score it in Spark and bring it.
No, you would absolutely score it in Spark. So what I'm saying is you'd score it in Spark and then you'd push the output to the data warehouse. So the whole point of Spark there is because Spark is great at building the model and helping score the model for all the data coming in, and then you get some result, right? The result of the probability of failure of the windmill is 25% or whatever. You add that as a dimension to a table in your data warehouse.
Right. You can do that. You can serve it that way from Spark. You can add that.
Okay, so I think what you're asking is, hey, I did all the calculations in Spark. I'm just, I can read the data out of Spark. Here's the very interesting thing. You can absolutely read the data out of Spark. But think about enterprises and where are the analysts asking the questions? You're correct that the data is available in Spark, but the business analyst who's working on, querying this data along with, thousands of other tables that has business data is unlikely to use Spark just for this task, right? Because things are abstracted out for him. He has some tool that probably doesn't even look like Spark. Maybe it's a BI tool that he's using that's already connected with the data warehouse. And in those cases, if you make the data warehouse much more intelligent, that analyst can start taking advantage of it. There's a question there and there.
I think we'll start over here.
We'll start there? Okay, go ahead, sir. The red shirt.
So one of the big challenges that we face is the ability to get the insights in a much faster way, right? So in other words, I would say it is 10 times cheaper to put the data in, 20 times expensive to get the data out. So in the modern data warehouse, what kind of tools and other products that you have where I want to get the data out for a different dimension, not just the primary key? So I was just wondering, you can talk about the ability to pull the data in a faster manner.
I'll try my best. I'll try to repeat the question. Like you're asking, what abilities do we have to get the data out? In my terminology, I call that serving. Like serving the data to either a reporting tool or for ad hoc analysis. And the SQL data warehouse, you can obviously query it using SQL. You can connect it to Excel, you can connect it to analysis services, you can connect it to Power BI, and there is a very large swath of third-party tools that you can connect it to get the insights out, if that's the question you were asking. I'm not sure if I answered your question, sir.
I'll give you an example. Druid is one thing that allows you to pull the data out much faster with different dimensions, right? So I was just wondering, what kind of tools do you have to do something like Druid?
So I'm not very familiar with that, so I'll follow up with you offline. But I'm going to come talk to you about that a little bit more. There was a question right here. He's bringing you a mic.
Yeah, hi. Yeah, I was just wondering, you said, I have noticed in Power BI you can connect to Spark. They have a connector between Power BI and Spark. I just wanted to know, do you see people doing that very often, or people normally connecting their BI tools to a data warehouse or through analysis?
So this is a great question. You saw on my slides, you've probably seen in documentation that you can connect Power BI directly. And so the question is like, why would you then pipe it through the data warehouse, right? So from an architecture, from a very base architecture perspective, right? If you just are thinking about the Spark world, yes, you would connect it to Power BI. But in reality, what's happening is the data warehouse already has a ton of information. You're not replacing it, you're augmenting it with these new insights or these new dimensions that came out of analysis in Spark. And that's the reason you would put it in the data warehouse. The other advantage is, at least today, look, all of these technologies are trying to go to the next level. Data warehouse is trying to do more ML, Spark is trying to do more serving, so we understand that. But today, the kinds of things that analysts need, both in terms of performance and in terms of flexibility to attach to their existing tools, that persona is already using a data warehouse. So it's much easier for you to add a dimension to tables in a data warehouse versus say, hey, for 95% of things that you're already doing, go here. For the 5% of these new things, go to Spark. And this is a very important takeaway, because if you do not start converging on the pattern as an organization, the data is going to start living in silos. So you can use the pattern that we recommend, or you can build a different pattern. Whichever approach you go with, I would not have data coming out of different silos, because then data is not going to get used. At least that's what we have observed from our customers.
So a question about aligning aligning dimensions generally. So we've got a whole bunch of data in a data warehouse, and it's organized in a certain way, and there are dimensions on products and regions and time, maybe it's by day and so on.
Yeah.
And now I bring in a bunch of new data from Spark, and a priori, the Spark system, unless I do a lot of work, doesn't align to those same dimensions. Maybe I'm getting IoT data by the minute or second or something. So do you have any tools or suggestions to make that easier, to align the data that you're going to bring in so it can...
I mean, I think I understand your problem. We obviously would like to do a deep dive with the customer, try to understand the scenario, but here's what I'd say. At a very high level, you want to do the transformations in this particular pattern in Spark, right? You want the data to be ready to be digested by the data warehouse. That's the whole point of putting Spark ahead of the data warehouse in the pattern. Like that's how I would do it without knowing any more details. Of course, things are nuanced in the real world, but in general, that's how I would do it. All right, thank you guys very much.